Hi, my name is Marisa Leung, and I'm a software engineer on the Environmental Insights team. I've been a part of this team since its inception, and I'm super excited to talk to you about our technology today. Thank you so much for joining. EIE is one of our most powerful and tactical tools, and it is completely free for people to use. It is geared towards helping cities take steps to climate action. Today, we're going to talk about what Environmental Insights Explorer, or EIE for short, is all about, its motivation as well as the problems that it solves. And then we're going to dive deeper into the data sets that we provide, such as transportation emissions, building emissions, solar rooftop potential, and air quality. And then we'll do a quick demo of the website so it becomes more tangible and you know what we're working with. And then we'll close out with some inspiring action stories of cities taking our data and running with it. So let's get started. So what is Environmental Insights Explorer? Let's start with the overarching issue at hand. The world is changing dramatically, and we have until 2030 to cut our CO2 emissions in half, and we have until 2050 to be completely carbon neutral in order to avoid the worst effects of climate change. According to the United Nations Human Settlement Program, also known as UN Habitat, about 70% of global emissions are attributable to cities. So even though worldwide cities only make about 2% of our land area, it still generates a 70% staggering amount of greenhouse gas emissions. So it makes sense for us to focus on cities and reducing emissions there. The good news is, cities can make infrastructure and policy changes to have meaningful impact on their carbon footprint, as well as the health of the entire planet. But while more than 10,000 cities have committed to taking action on climate change over the next decade, without the right data, it's really hard to know where to start. So of these 10,000 cities, less than 20% have been able to complete, submit, or monitor their greenhouse gas inventories. Why? Well, unsurprisingly, the process for building out a baseline emissions inventory can cost hundreds of thousands of dollars and can take months or even years to finish. In short, inventories are expensive and they're hard. That is where the Environmental Insights Explorer, or EIE for short, comes in. EIE is a free online resource where we organize data about a city's transportation emissions, building emissions, rooftop solar potential, and air quality. These are considered important indicators of a city's climate health. And with the help of partners like the Global Covenant of Mayors of Climate and Energy, we empower cities to measure, plan, and act for the betterment of their own city and for the rest of the world. Fun fact, our CEO, Sundar Pichai, just made a series of sustainability commitments, including this one: help over 500 cities to reduce 1 gigaton of carbon emissions annually by 2030. That's our team. So that's the summary of what EIE is. Let's go more into what the data sets are that we provide, beginning with transportation emissions. Transportation emissions are emissions that come out of moving vehicles, such as motorcycles, cars, buses, and cities traditionally measure this by sending out surveys to people who live in their city and figuring out where they're commuting, how often they're commuting, or sometimes cities will install road sensors on the road that will count every time a car or a bike goes over them. And sometimes I've even seen when cities don't have enough resources, they'll take their country level transportation emissions and they'll actually scale it down to their city size. So there are lots of different models to generate transportation emissions for inventories, but some of them are tricky and they have different data gaps. For example, when cities install road sensors, they usually only install them on main busy roads and not residential neighborhoods, which makes sense because it would be super expensive to install road sensors on every single road in a city. But because of that, they're missing a huge amount of movement activity. But now we have a solution for this. Our tool, EIE, uses aggregated location history data from devices, on which we've applied a number of privacy filters and aggregation and anonymization techniques. If you're familiar with Google Maps timeline, or even Google's COVID mobility reports, these are reports that chart movement trends over time, intended to provide insights on what has changed due to policy that combats COVID-19. This is the same type of data that we use. In EIE, this data takes into account movement over all major road classifications, so from interstates to local roads, and we use machine learning to determine the mode that people are traveling by. Are they walking? Are they driving? Are they busing and then getting off and then biking? And then we use population scaling techniques that are similar to the ones used by transportation models based on household travel surveys to finally scale to a city size and estimate the annual vehicle trips by mode and vehicle kilometers traveled, or VKT for short, for all the trips in a city. That is a lot of computation. We then combine these measurements with region-specific assumptions. For example, how much a typical bus in a region uses, how much fuel. And we generate the total emissions caused by transportation for the whole city, just like that. And the next data set we provide is building emissions. So buildings generate greenhouse gas emissions from direct combustion of fossil fuels, heating, for example, or indirectly from electricity that the residents or equipment in a building use. Using Google's proprietary data, we are able to estimate floor space and assign a building type category to most buildings within a city's boundary. We derive this floor area with data sourced from Google Maps imagery and 3D modeling. This should look pretty familiar to you. We take the footprint outline of the building and we calculate the base area, and then we multiply it by the number of floors in a building to get the total floor area. And then we categorize buildings as residential or non-residential. This is important because some building types use more energy than other building types. For example, a hospital is going to be using way more energy than a residential building where people maybe sleep, go to work, come back, but they're not using energy all the time like a hospital is. So we can use Google Maps business data to figure this out. For example, if there's a grocery store inside of a building, it's probably not a residential building, it's probably a non-residential building. And then we combine this data with region-specific assumptions again, such as the energy intensity of a square meter of a residential building or a city's energy fuel mix. And we combine all this data together to get the total building emissions result of a city. The next data set we offer is rooftop solar potential. This is super cool. This is an insight that shows how much energy could be generated by solar on rooftops, and in turn, how much emissions would be avoided. The way we calculate this is awesome. We use Google Maps imagery and 3D modeling, just like the building emissions. And for every single pixel on a rooftop, we calculate a bunch of things. We say, what is the angle of the roof at this pixel? Where is the sun for every hour of the day, and how much sunlight is it shining on that pixel? Are there any obstructions around, like chimneys or trees that are casting shadows? When is it cloudy in a city? And of course, can we even fit a solar panel on this pixel and surrounding pixels? We ask all these questions for every pixel on a rooftop. And then we do this for every single rooftop in a city until we cover the whole city. And that is how we get the total solar rooftop potential of a city. It's a lot of computation. And the last data feed I'll cover today is air quality. In the lab section of our website, that's where you can find it. This is street level air pollution measurements taken with mobile air sensors that were strapped onto street view cars. I mean, if the street view cars are driving around, you might as well have them take pictures and measure air quality, right? Air quality can vary drastically between and within city blocks. So this data gives us a clear look at those variances, and it ultimately gives us a deeper understanding of the air quality layout of a city and where actions could be taken to make things better. Whew. Okay, so that is a quick overview of what Environmental Insights Explorer is, as well as some of the data feeds. Nice job, we got through it. Now we're gonna do a quick demo to show you the website, and specifically we're gonna focus on the transportation emissions page, which is something that cities are really, really excited about because it's never been, something like this has never been available before. If you want to follow along, feel free to join me at insights.sustainability.google. This is the homepage of the Environmental Insights Explorer. From here, you can search for a city. Let's do a fun one like Kyoto, Japan. From here, this is the city summary page. You can see high-level overviews for building emissions, solar rooftop potential, and transportation emissions. If you want to see more in-depth details about each, you can click Explore and Customize. And here you'll see more in-depth data. So to the left, you can see the total CO2e per year generated by Kyoto in 2018. And then to the right, you can see the map where you can see the number of trips taken per year, inbound, outbound, and inboundary. And the difference between these three is where a trip has started and stopped. So for inbound trips, they've started outside of the boundary and ended inside of the boundary. And for inboundary trips, they've started and stopped inside of the boundary. Why do we divide it into three different types? This is because cities make their transportation emissions inventories differently. For example, some only count their in-boundary trips, whereas some cities will count their in-boundary trips and let's say 50% of their inbound and 50% of their outbound. So by giving them choices, cities can just take whatever numbers they need and plug it into the model that they use. So back to the left side, if you scroll down, you can see breakdowns of how people are traveling. Are more people commuting in? Are people moving more around inside of the city? And then if you scroll down even more, you can see how people are traveling. What is the distribution of trips? In Kyoto, I think this is awesome. Rail is clearly the most popular, followed by car and then walking. And then if you scroll down even more, you can see the total number of trips and a super important number, vehicle kilometers traveled, also known as vehicle miles traveled if you use miles. And this is a very important indicator used in most transportation emissions inventories. And if you scroll down even more, you can adjust values on specific data points. And if you do that, it will bring up a calculator. This calculator is super powerful and important and can be used for scenario planning, or if you have even better data or fresher data to put in. And you can watch how the main CO2e number changes at the top. So for example, let's say I'm Kyoto and I want to completely electrify my bus fleet. Then I would change the emissions factor and make it go to 0 and see that my emissions has reduced by about 130,000 tons of CO2e per year. So this is a super powerful tool to use. Feel free to play with it on your own. And if you just want a CSV of all this data, you just want the pure data to play with, there's this download icon to the upper right. And if you click it, you can see the building emissions data, the transportation, and the solar potential. And you can just download as a CSV and play with it. And that concludes our quick demo. We've gotten through the bulk of this presentation, and now I'd like to wrap up with a couple of inspiring city examples of them using our data. This first example is a city we've worked with a lot to validate both our buildings and our transportation data, Dublin, Ireland. So Dublin is historically a pretty car-heavy city, and you can see that on our website. But knowing the dangers of bad air quality has actually been a driving piece in them reconsidering how people actually get around in their city. With EIE, for the first time, they could see how many bike trips there were and get a better understanding of how bikes were used in their city. And this first time actually came with a baseline emissions inventory that they could also use to compare their progress to. So, with these two in hand, Dublin decided to go all in on bikes. They started a bunch of things, such as increasing bike lanes as well as making bike sharing programs. And this is a part of their Dublin Smart City program, which aims to increase bike trips by 20%. So they're pretty much giving their city a bike makeover. And the second piece of the story is that they plan to use EIE year over year to see snapshots of the biking and if they're increasing. In other words, to see their progress. Another example is Houston, Texas, which was actually quickly followed by Dallas, Texas. And they utilized our solar potential data and they saw how great they were with rooftop solar potential. So they decided to go all in and they launched plans to generate at least 5 million megawatt hours of renewably sourced energy. This is huge and brings a ton of green jobs to their cities. So that wraps up our presentation for today. Thank you so much for stopping by, and I hope you enjoy the rest of your summit.